This is problem 79 from chapter 13. The airplane traveling at a constant speed of 50 meters per second is executing a horizontal turn. If the plane is banked at an angle of 15 degrees when the pilot experiences only a normal force on the seat of the plane, which means no frictional force, determine the radius of curvature rho of the turn. Also, what is the normal force of the seat on the pilot if he has a mass of 70 kilograms? So the first thing we want to do is determine the tangential direction, the normal direction, and in this case, the binormal direction. So the tangential direction is the direction that the plane is going in, which in my picture is kind of coming out of the page. And the normal direction is in towards the center of the circle. So I can draw that. Normal direction is in towards the center of the circle. And then the tangential direction, which is this way, crossed with the normal direction gives you the binormal direction. So the binormal direction is pointing straight up along that vertical line. But the plane is banked at an angle of 15 degrees, so the plane's like that. So this is the binormal direction. So this is kind of an interesting problem because we have a component of the normal force in the binormal direction rather than all of the normal force in the binormal direction. So we're going to draw a free body diagram. We have the force of gravity pointing straight downward. The normal force is perpendicular to the surface of contact because the plane is tilted at an angle of 15 degrees. The seat of the plane would be like this, at an angle like this, where this is 15 degrees. So the normal force is perpendicular to that. So the normal force is pointing like this, where this angle, I'm just going to write theta there, but it's 15 degrees. Okay, so we have our non-contact force, which is the force of gravity. And the only thing touching the pilot is the seat, which is exerting a normal force but no frictional force. So we're done with our free body diagram. Well, not really, because we're going to now break down the normal force into normal and binormal components. So mg points straight downward. This is n cosine of 15 degrees. And this is n times sine of 15 degrees. Now we take a look at our equation sheet, and the sum of the forces in the binormal direction is 0, and the sum of the forces in the normal direction is the mass times the acceleration in the normal direction, which is v squared over rho. So in the binormal direction, we have n sine of 15 degrees is equal to m times g. We are looking for the normal force if the mass of the pilot is 70 kilograms. I didn't really plan out where I was going to write this, so we're just going to drop down here and say n is equal to m times g divided by sine of 15 degrees. The mass is 70 kilograms. G is 9.81 meters per second squared, and thus the mass of the pilot is, the normal force is 2,650.5 newtons, or we can say 2.65 kilonewtons. We also have to find the radius of curvature, and now that we know the normal force, this is going to be quite easy. So the normal force is, let's use 2,650.5 newtons. And then we have cosine of 15 degrees is equal to the mass of 70 kilograms times v squared. V is 50 meters per second over the radius of curvature, which is what we are looking for. So you can solve this for the radius of curvature, and you should get 68.35 meters.